Hey, welcome back to Mr. Precal. This is Unit 6, Topic 1, Lesson 2. We're going to go into permutations and combinations and the difference between the two and how to find them. Starting off with permutations. A permutation is when you're choosing objects and the order matters. So, for instance, you're watching a horse race and you want to know what the horses will finish in first, second, and third. So that means the order does matter, so therefore that would be a permutation. Or a combination lock that you're turning, and you want to put the first number in first, and then the second number, and the third number. If you put them in any other order, they're not going to work. So therefore that's a permutation, which kind of bugs me because they call it a combination lock. I don't know why. The number of permutations in n objects taken r at the time is denoted in npr. So as given by, so this notation of the fact that's n factorial divided by n minus r factorial. So basically what you're doing, and I'll show you the shortcut on the next slide, n represents the amount of different possible choices that you have, basically, and r means how many of them you're going to be choosing. So in the horse race, so let's say there's 8 horses, n would be 8, and r would be 3 because you're choosing first, second, and third. Or maybe you're choosing less, but in that case it would be 1, 2, it'd be 3. So that'd be 8p3 in that case. All right, so next one, so we're doing this without a calculator. So let's say that there are 11 different choices and you're choosing 3 of them. So it's going to be 11 times 10 times 9. All right, so pen fixed and times 9, and then we just multiply that. 11 times 10 times 9 gives us 990 different possible outcomes. 6p4, so that's going to be 6 times 5 times 4 times 3. That's the 4 numbers, the 4 highest numbers in 6 possible outcomes. 6 times 5 is 30, times 4 is 120, times 3 is 360. All right, so the next one's going to be a little bit trickier. So this one, it's going to be n on the first one, and then it's going to be multiplied by n minus 1, and then multiplied by n minus 2. Now, if I multiply these in any order I want, so I'm going to do this times this, and that's going to give me n squared minus 3n plus 2. And then multiply that by the n on the outside, and therefore it gives me an answer of n cubed minus 3n squared plus 2n. There's your answer for this one. Okay, now, the reason why this works for this one, and the reason why I did what I did using the formula, keep in mind it would be 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over n minus 3. So that would be 8 times 7 times 6 times 5 times 4. Now remember, that was on the formula at the top. So these 8s get canceled, the 7s get canceled, the 6s, the 5s, the 4s, the 3s, the 2s, the 1s. Everything gets canceled except for the 3 top numbers. So that's the reason why that's what you do. All right, so if you're wondering, based upon that equation, it is the exact same equation as this. I'm just doing the shortcut method of it. Or I can put it in the graphic calculator. Now, let me show you how to do that pretty quickly. So you got to put in 11 first, and then press Math. Go over to the right where it says Probability. That should be the 4th tab. Go down to where it says NPR, so that'd be choice number 2 on my calculator, and then put in the 3. And it looks like this. Keep in mind, I know my picture's flipped. Press Enter, and it's going to say 990. There you go. All right, combinations. Combination is when the order does not matter. So if you have 100 names in a hat and you're just pulling out 5 random names, does not matter what order I choose it in. I want to know how many different ways can I pick 5 names. That would be a combination. So therefore, the order does not matter. So for this question, it's a little bit more complicated. You do n factorial divided by r factorial times n minus r factorial. Okay. So once again, you can also put these in the calculator. I know that's not what it says on the first question, but I'm kind of cheated due to time. So 10 math, I go over to probability, choose NCR 7. So it's kind of the same method I did a second ago. And then press enter and you get 120 possible outcomes. Okay, so now in each one of these scenarios down here, I'm going to choose, is it a combination or permutation? So the difference between the two is just whether or not the order matters. So if you have 25 people to choose from, you're choosing a president, vice president, and secretary, the order does matter because that will depend on what job that you're doing. So that is a permutation. Cook chooses 5 potatoes out of a bag of 12. How many different ways can you choose 5 different potatoes? Now, does it matter what order you pick the 5 potatoes in, or you put them into the pot? No, it does not. So It's just a combination, because the order of choosing the apples. Doesn't matter if you chose a potato first or second or third or fourth, it's going to go into the pot. A teacher makes a seating chart of 22 students in a class with 30 desks. Does the order matter? Sure it does, because every single way that you could make it is going to have you in a different seat sitting next to different people, or maybe not sitting next to anybody, because there's 30 desks and only 22 students. So the order does matter. Now, for these next two questions, these are fundamental counting principle questions. So if you have 4 candidates for prom and for prom queen and 3 candidates for king, that means that there's a total of 12 different possible outcomes that could occur. From town from A to B has 4 roads, and B to C has, okay, 3 from town A to B and 4 from B to C. That means there's 12 different ways to get from A to C if you go to B in between. All right, how many different license plates consist of 5 symbols, either digits or letters? Now, there's 26 letters, and then there's 10 possible single digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a grand total of 36 possible symbols. I guess I'm just going to use the word that's in here. So there's 36 different possible symbols, either numbers or letters, that could be chosen for each spot on a license plate. So if we know that there's 5 spots, so does the order matter? Sure it does, because whether or not you have an A first or last is going to make a completely different license plate. So the order does matter. So this is 36 possible outcomes, and you're choosing 5 of them. So that's what I put in the calculator. I put 25 math, permutation, 5, enter, and we get 1, 2, 3, 1, 2, 3. It looks like there's a lot. 6,375,600 different ways to make that license plate with just 5 digits. Now, keep in mind that real license plates, I believe, has 7 digits, so it's going to make even way larger of a number. A 3-woman committee is to be elected from 25-member society. How many different ways can you elect a committee? Well, it doesn't really matter if you're chosen first or last. If you're chosen, you're on the committee. So the order does not matter. So whether or not you get chosen first or second or third or fourth or fifth doesn't matter. So this is definitely a combination. There's 25 people to choose from, and you're choosing 3 of them. So 25 combination of 3 choices is 2,300 different ways you could choose a committee. 16 actors for casting call to try out for the roles of 7 dwarfs and a product of 7 Snow White and 7 dwarfs. And how many different ways can the director cast the 7 roles? Now, this is actually, you got to be particular to the question. Now, if it was just saying, you know, how many different ways could you choose 7 actors, then that would have been a combination. But it says how many different ways can a director cast the 7 roles? Well, that means that we want to know how many different ways can one actor be chosen for Sleepy, all the other ones, whatever they all are. I don't know them, sorry. So therefore, the order does matter because they're all different characters. So this is a permutation based upon the way that this question's worded. This is a pretty tricky one. So there's 16 possible actors, and you're choosing 7 different roles. So 16 math, and then permutation of 7, and you should be getting something that looks like this. 1, 2, 3, 1, 2, 3. So 57,657,600 different ways you could cast them. It's a lot of ways. And that looks like that's it. So please give this video a like if I helped you learn how to do permutations and combinations and the difference between the two and distinguishing whether or not each question or scenario is one or the other. Remember, permutation, order matters, combination, it doesn't. And a combination lock on a locker is a lie. It should be called a permutation lock. Thanks again for watching. Have a great day.